talking about points of concurrency, and we have two more points of concurrency that we need to discuss. And they are called the median and the altitude. Now, we've discussed medians in other areas of math. So, based on what you already know, what do you think a median might be? The middle. Just like the middle of the road is called a median. So, always think of that as the middle. So how can we find a median in a triangle? Well, the median is going to start at the middle of the line, and it's going to go to the vertex opposite it. So we'll find the middle of the line and go to the opposite vertex. And again, middle of the line to the opposite vertex. There, I missed it when I went that way, but when I go this way it works better. So this point of concurrency, these lines are called the medians. The point of concurrency is called the centroid. And again, what does centroid sound like? It sounds like the center. So middle and center go together. Now, the neat thing about the centroid is that it divides the line into thirds. Sort of. So this part of the line is 2/3 of the line, and this part of the line is 1/3 of the line. So how can we figure out how long a line is then? Let's say this whole line is 15. So line AB equals 15. So I want to divide it up into thirds. So how would I do that? Just divide 15 by 3, and what do I get? 5. So I put a 5 here, a 5 here, and a 5 here. And then I have 3 of them. Those are my thirds. So to get this part of the line, 2/3, I'll just take 2 of them. So AM, segment AM, is equal to 10. And segment BM is equal to 5. What if I then said that AM is equal to 8? How long is my total line? Well, AM is going to represent 2/3 of the line. So if I divide it in half, that'll give me 4. So I put a 4 here and a 4 here. And I have to have the same number here, so I'm going to have a 4 here. So my total line then would be 4 plus 4 plus 4, or 4 times 3, which would be 12. So my line AB then is going to be 12. And of course, this segment is going to be the other 4 here. Okay, so that's centroids. Let's talk about, or that's medians and centroids. Let's talk about the altitude then. So let's talk about the altitude then. Altitude is height. How high is it? So an altitude is the height of a triangle, which you've dealt with before. Just means that we're going to drop a perpendicular from the vertex, because that's going to give us the height. Sometimes gets a little tricky when we're going sideways, so you might want to use measuring tools to get that, to get it accurate. and drop a perpendicular. And these are called our altitudes. And our point of concurrency is called the orthocenter. Now when I think of ortho, I think of like the orthodontist. And what does an orthodontist do? They move teeth. So that means it moves. So the orthocenter is the only point of concurrency that can actually occur outside the triangle. Let's see how that looks. If we have, and this is tricky to draw sometimes, an obtuse triangle, and I start trying to drop perpendiculars, my perpendicular is actually going to be like this, and like this, and like this. Oh, I missed. Like this. And so my orthocenter will be outside of the triangle. Point of concurrency, orthocenter. What good does the orthocenter do us? It really doesn't do us any good at all, but altitudes are good. They're helpful. And you'll know that you have your altitudes correct if you get a point of concurrency. Thanks for watching. Have fun. Thank you for watching Super Math Mommy on medians and altitudes. If you found this video helpful and would like to learn more, click there to subscribe. Our next video should be there. If it's not, it will be soon. Now, if you missed the previous video on angle bisectors, click here. Are you still there? Click somewhere.